Okay, in the previous video we worked out the T1 and T2 for the estimation for the VIX index. So overall we need to put T1 and T2 into this formula to estimate the variance of the option chain data. So let's go back to the estimation again and look at the raw data. And the data here is option chain data for the near-term contract and for the next term. So we had previously mentioned this was 25 days and 32 days too, the respective expirations. And then the range of data that we use here, we don't use every single bit of data here. In fact, we are limited to data that is not stale. So when we find that there's a bid on a contract and we have two consecutive zeros, then we don't go any further in terms of our data range. Okay, so that's one of the nuances here. And again, when we estimate the VIX, it's not always clear that there is a constant number of strikes for each VIX estimation. The number of contracts that are included will vary going from day to day, perhaps even from hour to hour. Okay, so okay, in terms of the methodology then, one of the things we've got to find out is this F, right? So if we follow the sequence of notation here, there's a forward index level desired for the index option price, and that's related to the first strike price below the forward index level. And then the strike price KI is the strike price of the out of the money option. So for a call, KI is greater than K0, and for put, KI is less than K0. Okay, so we're looking for to establish what the magnitude of F is. When we try to estimate F, okay, we take the strike price. Okay, so there's a particular strike price to which we add the exponential term to the power of the interest rate and the respective maturity, and then the difference in the call price and the put price. In this estimation, unlike other implied volatility estimates, normally we use the spot price in the market. In this instance here, we're not going to do that. We're not going to use the immediately observable futures price. What we look at here is F derived from working out the difference between where the absolute difference between the call and the put is at a minimum. So if you like, to get this strike price of 1965 in the case of the first of the closest maturity, we look for where the difference between the call and the put is lowest, and then we can assign that 1965 to F1, and then E we have in terms of a interest rate that's already been given. That's derived from a treasury bill, right? So the R1 and R2 are the respective interest rates for time period 1 and time period 2, and notice that it's 0.03 of a percent, and again R2 is 0.02 of a percent. So when expressed in a decimal form, okay, the zero, it becomes 0.00305, and again for this the longer interest rate 0.00286. Okay, now if we take our raw data, let's go back into the spreadsheet for a moment, and we have a look at the appendix. Right, and I come down a moment. So that's what was given in the paper. Let's bring that a little bit closer. And we've this 21 and 23. Okay, so this is for the near term option contracts, 21.05 and 23.15. Now that's not immediately obvious here, right? And what we've got to observe is that we are looking at, maybe we can freeze. If I come here in the worksheet and go to view and then freeze and freeze panes. Okay, and then we'll come down, and then let's take a look at the actual data in question. Okay, so in the methodology that's provided with the VIX implementation document, for the earlier contract, F is given as the strike price associated with where the difference between the call. Now this is the mid value of the call, offer and spread. Okay, offer and bid. Okay, so I should have come down one further. Unfreeze view, freeze panes, unfreeze, and then we'll try that again. Freeze panes, and then we come back up. Okay, so in the data that's provided in terms of the option chain data, we have bid and ask for the call, bid and ask for the put. Okay, now if we take the midpoint of the bid and the ask, we get 24.25. So that's for the call, right? This is true for the call. Okay, and then when we come to the put, right, the midpoint is 20.6 plus 22 divided by 2. So the 24.25 here is consistent with the average of the bid and the ask for the calls, and likewise the average for the bid and the ask for the puts is 21.30, and that's what we have here. And then the difference between the two, if we just take the difference between the two, it's 295. Okay, now the values that we have here go from being positive to being negative. We want the minimum value, but it should be the absolute. So we should take the absolute value of the difference. So 295, we come down. If we take the absolute value below, it's 210, 695, and 1250. And we could do that for all of them in the process, but we find here that the minimum difference on the bid ask is 210 in the whole series. We could replicate this entire column here. I haven't done that, just for purposes of keeping everything brief. But we have 210 here is the lowest value in terms of the differences between the call and the put difference. And as a result, because we have that 210 here, we identify then 1965. And as a result, then if we want to replicate F1 here for a moment, so let's just take a snapshot. Okay, I'll copy. I'll go back into the spreadsheet. Okay, and put this to one side for a moment. Right, and home, paste. Now if I want to estimate F1, here what I've got to note is F1 is equal to the value associated with the minimum difference between the call and the put. It's an absolute difference. It's 1965, and then I add to that the interest rate, right? So there's an interest rate associated with the shorter maturity, the 0.000305, and that's a quote that we get from the methodology by the respective time period, right? And recall that the time period, right, the time period here was given as the 0.06834. Okay, so the respective time period that we had was equal to multiply by 0.0683486, multiplied in turn by the midpoint associated with this lowest absolute difference, so the midpoint of the call. So the call here minus the midpoints of the bid ask on the put, the 23.15. When we make that estimate, we've 1962.9, and we can set out the similar for the put option, for the next, for F2 then. Okay, we repeat that exercise, and that instance for the put option, again, they're not aligned here, but if we come down, let's copy this again, copy, and come back up to where we might be able to find. So let's go to 10600. So what we've got to do, in fact, is find 1960. So 1960. Okay, so let's paste. To get F2, we have to find why is it this exercise price of 1960. So again, I'll pause here and set out a few numbers. So we have to determine why is it 1960 is the appropriate strike that we use here for calculating F2. What I've done here is I've taken the mid value between the bid and the ask for the call for the longer term, longer dated contract, and likewise for the put contract, the bid and the ask divided by 2. So I'm taking the mid values, I pull those down, right, I get a series of values. When I say, look, take the absolute of the difference between call and the put, okay, and we come down, we find that the value is minimized here at 240, which is consistent with the 196. Okay, so this 1960 for the strike is consistent with the minimum difference between the mid call and mid put prices for bid, respective bid and asks. Okay, and once I identified that it's 1960, I put that in, and as before, we then find what the appropriate interest rate is. It's very small for our 2, and I multiplied that by the respective time period. Where did I get that time period? We got it before here when we worked out T2, so that respective time period is T2, and then we take again the difference between the 2730 minus the 2490, and I get 1960. 6040.